Right. I'm Dr. Bob Zellmann. I teach philosophy, psychology, and religion here. I've been here for, 18 years, quite a long time. And this is the continuing series of people coming to speak about a variety of topics. And mine's on curiosity, and it's about Eratosthenes. I hope that's a name that you'll never forget. But it's about being curious. I think we're all curious creatures. So I'm going to get started, talk for about 20 minutes, and then if you have any thoughts or comments or questions, feel free to ask. So anything before we start? Welcome and thank you. So, I need my clicker. By the way, you're witnessing the second PowerPoint I've ever done in my life, right here. This is it. This is the second one. Hopefully the last one. No, we'll see. That's real. That's real. All right. Eratosthenes, one curious dude using the regularities of nature to calculate in order to know something, real knowledge. Greek philosophy is about trying to know what's really real, what's really true. Like true with a capital T, not true relative to what people believe or feel. And so that's what this is about, that progression. And Eratosthenes used amazing amounts of math to figure out an incredible thing for his time period. So here we start. Philosophy is the love of wisdom. It's built on wonder, curiosity. Those things are its source and provide its energy, its drive, and foundation. Philosophers are curious about many things and offer an amazing assortment of questions and answers and a process of reason and arguments to ask and try to find out what is real, what's really real, what is true, and what does the good mean, and how do we know any and all of these things for certain. And if you've taken any of my classes, you try to do this reasoning by attacking the argument, not the person. Boy, would that change Facebook. You attack the argument, not the person. Imagine that in politics. I think half these people would know what to say. But here we go. To be human is to be curious. It's as natural and as good as can be. It's biological. It's who we are at our core and at our best. It's investigative. It allows us to survive, to gain power, to plan for the future. So let's be curious. It goes with being human. Many of you, like me, might just need the History Channel, a few PBS shows, and a few podcasts, and you would be happy. Seriously, that's all the entertainment I would ever need. These shows are built on feeding those who want to know the whys and hows of things and events and people. So before we go any further, one of the most important things that philosophers do over and over and over again is define things. So I'm going to use a little bit of defining here. To define means something you set off the boundaries of something from something else so that you know what you're talking about. Because one of the easiest things to do is to talk past something. If I asked you a question of God, there's 65 different ideas about God and we haven't defined anything, so people talk past each other and it's a source of confusion. So we're going to try to define this a little bit. So before we go any further, philosophy is very interested in definitions as a starting point, to set the table, so to speak. So to begin with, we need to clarify the meaning, issue, or nature of any topic or thing, and in this case, it's curiosity. What? There we go, there you go. So, definitions are starting point in philosophy. Definition, small letters, but here we go. Means eager to know, desirous to know from the 1300s, desirous of seeing, often in a bad sense, wrought with desiring, and or care or art. Remember, art here means artificial. When you hear something art, it's hands do it. Nature doesn't do it, you do it. So that's what art is. Art is short for artificial, right? It's doing. It's not of nature, but by human hand. Diligent, meddlesome. Now this is exciting. The words exciting curiosity was a euphemism for erotic porn in England. Of course it was. But anyway, curiosa meant porn in England in 1883. So, okay, gosh. It means inquisitive, prying, and those words came later. It can also mean, to be incurious meant careless, unconcerned, negligent. The root of the word, though, is cure, which means care or concern or trouble. Curiouser and curiouser is the famous line from Alice's Adventure in Wonderland by Lewis Carroll. You should check that book out. It is a curious thing. So, there was once a curious man named Eratosthenes, I want to tell you his story and his ingenious use of a principle, observation, and geometry that allowed him to figure out a way to calculate the size of the circumference of the Earth 2,300 years ago. There were no telescopes, not even science existed, and yet he did it. He figured out a method while also realizing at the same time that the Earth isn't round, or the Earth isn't flat. Ancient Greek astronomy was the study of the universe to understand how it functioned, why, apart from the established theistic, the God models. It's easy to go, God did everything, but that doesn't explain anything. They wanted a more naturalistic, non-theistic explanation. Ancient Greek astronomers relied on observation and mathematical calculation and patterns to determine the operation of the universe and our place within it. Math was the secret revelatory calculative means to understand not only what was truthfully, but revealed and was undeniable. It revealed undeniable principles about reality, structure, size, and space. To understand the first principles of fixed truths about reality was a large part of the Greeks' love of numbers. Geometry was the use of explaining shapes using numbers. Once you understand the principles of a thing, you can build a model, for instance, and test some of your ideas. Once you know the basic principles, you can blow it up or make it smaller, and the principles generally work. Models work. One of my favorite movies from my childhood is called Flight of the Phoenix. Has anyone ever seen this? It's the true story from World War II about men stranded in the Sahara Desert after their plane crashes. Desperate, one of the fellows steps forward, offering to build a new plane out of the pieces of the old one to fly out. It's their only hope to survive. After all, he had designed planes his entire life. Dramatically, just before takeoff, they realized he had only designed model airplanes. He had never designed an actual plane, but model airplanes. And there's this wonderful moment of doubt, surprise, and terror amongst the men, wondering, will this thing fly? Will it fly? If you understand the general workings and principles of something, they logically will often scale up or down and still work. It really did work. The men got out of the desert. So it's truly powerful to feel that you have some sense of control and understanding about the underlying unseen principles of how things work. When you know the principles of things, when your car breaks and you know how the principles of a car work, you're not afraid. It's not magic. You turn a key and it's magic. You actually understand that it's a system, and you live with more power and less fear. The plane work. The principles and scale often generally are not subjective, but universal. They're objective. It works time and time again, regardless of beliefs and opinions. And that's real knowledge. That doesn't change. For the ancient Greeks, questions that we might consider scientific were a part of what was called natural philosophy then. Each branch of science broke off from natural philosophy and became its own outstanding area of study. Chemistry, geology, astronomy, physics, psychology broke off only about 125 years ago. And that began partly with William James writing the first intro to psych text, which is actually still a good read. Now onto the principles of one of the most amazing uses of understanding principles. In the beginning, this began with Thales of Miletus. Various Hellenistic Greek thinkers began to offer non-theistic explanations for the natural phenomena. This line of thought was developed by the pre-Socratics, prior to Socrates, because they lived before Socrates of Athens. But this is a story of how insight and the theoretical use of principles, along with some data, can lead to amazingly accurate results. On to Eratosthenes and his method. So there he is. All right. Eratosthenes was the brilliant librarian at Alexandria and ingeniously figured out a way to answer this question. How big is the Earth, its circumference? He relied on Euclid's principles, which had already existed for hundreds of years, about angles, that right angles always have 90 degrees, always a sum of 180 degrees across a straight line, and there are 360 degrees in a circle. Geometry is one of the most useful and practical and visually demonstrable parts of mathematics, which is why I like it, because I can see it, right? Using these principles, you know a lot about a circle and the equality of its parts when it's evenly divided. He wasn't sure, but he believed that the Earth wasn't flat. He guessed the Earth was round because the shadow it cast on the moon during eclipses. You know, you see the circle on the moon, you go, oh, maybe the Earth is round. He also knew that on a flat Earth, the shadow cast on an obelisk is like the Washington Monument, An obelisk that's straight in one place where the sun shines down directly on it and there's no shadow, you go 100 miles away and there's an obelisk and there's a shadow. If the earth was flat, those shadows would be exactly the same. There wouldn't be a tilted shadow. Both of them would have no shadow at all, but that's not the case. One would be straight and one would have a shadow, which meant the surface was curved, as he figured out. That's pretty insightful to start with there. The earth had to be curved to explain this, he thought. He also had to assume that the sun was very distant, which it is, 93 million miles away. It takes about 8 minutes for light to get here, which of course he didn't know. But the distant sun allows you to assume that the sun's rays are straight. And this is an important part of this equation, that they don't wiggle, they're not crooked. Straight lines, therefore, shadow lines are therefore fairly crisp. Here's what he did. He used the straight sides of a water well, a hole in the ground, and he dug for drawing drinking water, and the shadow of an obelisk at a distant town. And he made observations and measurements at a particular time and day of the calendar in two cities at the same time in two distant places. One of the two cities was Alexandria, and another one was Syene, today known as Aswan, on the same north-south line of longitude. That's the imaginary lines that run up and down north-south on the planet here. By extending those lines of measurement of the sun and the shadow taken at the same time and the same day, using the well as a straight line. If you look here, the sun was straight overhead. This is a straight line. He drew the line and extended it to the center of the earth, knowing that the earth is curved. And then this line, this is one of the towers here. There's a shadow in here. Well, the shadow in here, this angle is exactly what this angle is. And I'm giving it all the way here. If you know that how far this distance is, and you know that a circle is made out of 360 degrees, this turns out to be 7 degrees. 7 degrees is 1/50th of a circle. If I know what the distance between here is, I multiply this times 50, and I end up with a pretty good guess of how big the Earth was. This is what he did 2,300 years ago. By extending these lines of measurements of sunlight in the shadow taken at the same time, the same day, he now has a straight line going to the center of the earth, and the other showed an angle of 7 degrees. If he knows the earth is round, 360 degrees, and he now knows that the wells have 7 degrees of arc between them, and that 7 degrees is 1/50th of a circle, knowing the accurate distance between the two towns mean that the distance is 1/50th. Oh, look at that. Since he knew the distance of the cities as approximately 5,000, called stadia at the time, stadia, he hired a man to walk the distance to tell him that distance. That length measured would be 1/50th of the size of the planet, the size of the planet. A stadia is approximately 1/10 of a mile, is the guess. The length of the arc, the distance between the towns, was 5,000 stadia. So if you measure that out, 5,000 times 50 is about 25,000 miles. And his guess, we don't know what stadia were, so it's somewhere between 24 and 28,000 miles. That was his guess. Now what's amazing is the Earth is actually approximately 24,901 miles. His curiosity, observations, and insights and use of geometry and available physical data led him to this astonishingly accurate calculation over 2,300 years ago. Now there are some errors. There's sort of the math for you there. There are some errors. His towns aren't exactly on the lines north and south like he assumed, and the calculations aren't perfect. And the Earth isn't actually perfectly round. It's more of an ellipsoid, actually. But this was a curious fellow who was able to figure out something that was astonishing for his time. And so I want you to think about what kind of curious things can you figure out, because there's a lot we don't know. You know, actually, the more you know we don't know. Seriously, go into science and we just don't know some basic things. We don't know a lot about people. We don't know a lot about cancer. So who are you? What's your curiosity, and where is it going to lead you? And how curious are you? And what energies are you going to use to continue to try to find out what you want to know? It takes will. It takes a lot of whys and hows in researching what you have to develop a new idea or just to sate your curiosity. You have Google. I hope you are also in the Look It Up Club. and that you look up whatever you find. I don't know what this is, look it up. It's not nice at the table. I have a friend who always, whenever he uses a word, he looks it up, and I'm like, hey, just eat. We'll look it up later. But but he's that curious. It's kind of nice. But don't stop there. Perhaps one of your questions and its answers may be one of the ideas that changes our lives for the better. Research, join others, try, go to graduate school. Right? There are lots of little things still to invent, to fix, to resolve, to make. We know so little. It's the most natural thing to try, so try. Look at what Eratosthenes achieved. Got some quotes here. We'll finish with that. Curiosity is one of the most permanent and certain characteristics of a vigorous intellect. How curious are you? And what happened to your curiosity at school? It's kind of like art. I hope it didn't get squished or squashed out of you at school, right? Asking questions is a good thing. Love is 3/4 curiosity. You need to know who Casanova is and what that means, but that's just kind of an interesting quote right there. So I'll stop with that. And then, anyway, healthy curiosity kills ignorance. It doesn't kill cats. That's mine. So, all right. Be curious, ask questions, and continue to do so. That's all I have. Any thought, result, something you're curious about? It's just a lot of random information. Yeah.
Do you know if there was a second guy who made a guess, and like who made the second guess?
Oh, now that's a good astronomical question. I don't know that actually. And what's interesting is that you asked that question. Like, what happened to this? There were two people who came up with the atomic theory 2,500 years ago, and they guessed. Leucippus and Democritus actually said, hey, the pre-Socratics said, hey, you know what? Maybe everything is small little pieces of things, and they call them atoms, which means Greek for that which cannot be cut. And they got this idea from watching Greek dancers, and they watched Greek dancers, and what do Greek dancers do? They wear tights and stuff, but they dance around, and they hook arms sometimes in a group, and then sometimes they swing off by themselves, and they go, maybe that's what's happening. Little tiny Velcro pieces, they didn't have Velcro, but little tiny pieces that hook together and don't hook. And they came up with that, and then it was forgotten. So it's an interesting thing to sort of find out the history of what did people 1,000 years later think and know about this, or were they fairly clear that the Earth is round? And I don't know those kinds of things. But anyone know? Somebody here? And this is a Google question. Ding, ding, ding. Not that Google knows everything, but that's a great question, and I don't know. But, I know that we used to think that the universe was perfect and then it moved in circles, and that the Earth was the center of it all. This is the early religious beliefs, right? Because God's going to put what God thinks is at the center of the Earth. This is the geocentric theory, and it's all the Earth, and it's in perfect circles. And then, Galileo and other people. Galileo took the telescope was invented by Jan Lippershey. He was making lenses. He's a Dutch lens maker, and he just took two, and he went like this, and he could see a church steeple suddenly, and he went, what the heck? And it was suddenly close, and then Galileo put a tube on it, and then Galileo looked at everything, probably in people's windows. I don't know. Probably. And then what? Don't do this. He looked at the sun. He looked at the sun. Anyway. But he asked a lot of questions. He said, it doesn't look like the Earth's at the center. And so asking more questions, politically, depending on where you are and who you're with conservatives, can lead to trouble or to breakthroughs. And so the things are in more of an oval rather than in a straight line. And that was kind of an interesting thing. All born by curiosity and asking questions. So, what's the question you have today? Anyone have any thoughts? What do we need to solve? Go ahead.
Okay.
Go ahead.
All right, here's my question.
All right.
If you feel like your curiosity's been squashed, do you have any advice for unsquishing it?
Wow, that's a great question. Some of this is set by your family, and maybe you have that odd person in the family who always asks questions, and sometimes questions can be very uncomfortable, but I think if you're trying to get to the root of that, what's that movie? You Can Handle the Truth. I know they say you can't handle the truth, but I think you can handle the truth. And I think that's one of the things that any curious person wants to know. I want to know the truth. I want to know what happens to me. I want to know whether God exists. I want to know, what's going to be here 1,000 years from now. I blow my students away when I tell them 40,000 years ago was ice. This was ice. This was ice here. What? No, yes, this was all ice. It changes. It's just mind-blowing. So what kind of things do you want to go to graduate school to try to discover and get on some team and figure something out? Or do we even have inventors anymore? Do we have any inventors in here, people who try? And I'm not just talking about an app to make $1 million. I'm talking about like you actually make something that, you know, anybody? Thoughts? Comments? Well, I want to, going to school, finding like-minded friends may be a way of doing that. And you may need to get away from your family or friends so that you can go out and go do your own kind of thing. And curiosity is the most natural thing in the world, and it ought not to be quashed. There may be a time and place for it, right? There's some of that social kind of aspect of it. It's the most natural thing in the world. And I hope school is a place where you don't feel like you're squashed at some level. Although, you know, there are people in the room here who know more than you do. There's probably people in the room here who know more than me. But the trick here is that, you know, you listen and we use reasoning to try to come to some conclusion, not just power or somebody's feelings. And that's why I think philosophy is just so important. Just so important. To try to really figure out what's really real. And how do we do that? Come to some conclusions that are tentative and then figure out new ones. So, any other thoughts? Great question. You just got to do it. That's what you got to do. You just got to do it. It's not easy. You might not even be rewarded for it, but you still got to try. You got to live with yourself first. You got to live with yourself first. Figure it out. Well, thank you. Have a great day.